Okay, welcome back to the Dublin Academy Maths. Now today we're on episode 6, okay, and we're doing these expected values and probabilities, okay. So now expected values, I'm going to read out something here that might answer a couple of questions anyway, make it clear. Expected values, or EV or EX, is where the random variable will repeat the answer an infinite number of times. And it's using probability density functions such as population studies, this is a population studies, and finite studies. Now finite possibilities is in a roll of a dice. No matter how many times you throw it, you know that a certain number will come up within a certain amount of times of throwing it. Okay, so it's a finite possibilities, and this is a household is randomly selected, so this is not finite. Okay, so how we calculate the probability. Okay, so I'm going to read out, this is question 7C 2011, and it says a household is randomly selected from among a households of 2006. Now we did this question before. We did the start film when we were doing when we were calculating the mean and such. Okay, now we had it like this. It was a graph, okay. It was a table, and we got 2006, and we got the number of people across the top in the households. Okay, so what is the probability has 7 or 8 people? Well, we collected in 2006. We had this. There's 15,141 7 people, and there was households, and there was 5,050 households had 8 people. Now I hope that makes it clear. I'll just run this over, and it says. Here's the answer to this. So there was 15,000 households in 2006, and 8 people was 5,050 households. Over the total sample size, add them and then divide, and you get out a probability of 0.01. Okay. Now the next question, part of that question, was the expected value. Now the expected value is what you should expect when you randomly pick something, okay? So from random variables, but there is this type of finite dependency on it, okay? Because the population or the household study, it should reoccur all the time, okay? Now it reads here, 1,000 households are to be randomly selected from among all the households in 2006. So 1,000 from the total of 2,000. Let X represent the number of 4-person households selected. Find E of X, the expected value. Okay, so up to 4. So you'd have to go up to 4 and add the previous numbers. There it is there. You'd have to add them all, the previous, and put it over the total sample size, and then multiply it by 1,000, because actually that is the sample size you're taking, but this is the overall population. Okay? Or the whole set. Okay, as such. So you multiply by 1,000. In other words, 1,000 has given it a sample size you've taken from, and it's just predicted how many. It's a very high prediction probability. So in other words, you will find that with such a high possibility, it means that you will find a lot of people existing in families of 3 or 4 in 2006. Okay, so it's very high probability. Now this question, question 7C 2011 is quite interesting. Okay, now there's a few things here, but you have to look at them to find them out. Okay, Connor was showing rapid growth, as you can see in the bar charts here. This is a bar chart. Okay, not a histogram. You can see that 2006. This is 2006. This is 1926. You can see that the population is 0.6 to 1.4, has almost doubled. Okay. And Fiona was trying to show that there is a reduction in, if you looked at here, you could see that the sizes between the bars of 2 people is increasing, so you can show that 2 is increasing, the number of people in the household is increasing with 2 people in it. Okay, and the number of households have doubled. This is showing you here roughly what this one has been doing. Okay, now a household, we've done this one, a household selected. Okay, we've done the 2 of these, and now I'm just going to look at these bar graphs here now. It says describe what difference there are between the 2 distributions. Okay, percentage of 1 to 2 households in Dublin. Okay, now you have to look at this graph to start looking, to make space to make sense of it. But anyway, you remember that the area of these bar graphs is related to the frequency. Okay, Now you can find the frequency very easily, okay? And the frequency is, so you can give her, these are actually related in percentages. Let's have a look at this question. So there are approximately 81,000 households in South Dublin. 81,000 in South Dublin. Approximately how many people live in 4-person households in Dublin? 4-person households in Dublin. So up to 4, so you'd add A, B, C and D because are 1, 2 and 3-person and 4-person households, and it's equal to 80%. These all equal to add up to 80%. If you look at 15, you see them, the percentages marked and you add them up. So you just get 80% of 81,000 households. Okay? What is the median size? Well, the median size is 2. As you can see, 2 is very high up here. So this is the median size. Okay? Is 2 people and a person selected from 11. Okay, we can look at that later. That's another one. So that's 2006, 2011, question 7C, and I'm going to have a look at 2011 paper 225. Okay, just a quick look here. I'm trying to get these all out of the way. Now, this is 2011 and it's a sample paper, okay? It's a sample here, it's 2011, and it's got these histograms, okay? Now, I'm not going to do these because they're very easy. The median, it asks you for the median and it asks you for which is the most used and all that. Okay, we got a scattergram here. Right, now there's the line of best fits. You make your correlations, okay? Okay, now the correlation coefficient between the times of these two events is one of the numbers below. Okay, she had cycle time. She had the time in minutes and she had the run time in minutes. So scattergram was playing one off against the other. We did scattergrams, I think. Yeah, we did scatter plots. Okay, so you're going from running against cycling, so you're one out against the other, and it says write the letter. Now this scattergram seems to be don't you see that it's nearly close to the line of best fit there, you know, that's the line I put in, that y is equal to x, you know, that's the line, or x is equal to y, whichever way you want to look at it. That's the line y is equal to x, and you can see that this is kind of conforming, they're conforming to the line. In other words, the spread is not too wild, it's not chaotic, okay? It's not chaos here, okay? So there's some sort of normality about it. Now that means it's got a positive, it's in a positive slope anyway, so you've got 3 numbers here, okay? You've got 0.75, 0.77, so these slopes, these probabilities go from +1 to -1, okay? So the probability goes from +1 to -1. There's no probability, doesn't have a minus. Doesn't have a minus, less than 0. It's not less than 0. No. Okay, so it's not less than 0. But it could have a negative slope. Okay, so it's going down, it could have a negative slope. But because it's going positive, it's positive slope. Because they're near enough to 1, it's 0.77. There's not 0.95 here and 0.77 and 0.13. But because it's near enough to 1, because this line is near enough but not exactly 1, because there's a few out here, it's close enough to 0.77. So the answer to that is 0.77. The correlation coefficient. Now we're dealing with the correlation coefficient, not the probability. Here I got a bit mixed up. So the correlation coefficient goes from +1 to -1. -1 has got a negative slope. +1 has got a positive slope. -1 it would have chaos. Plus near enough down along the line it would be, you know, unchaotic. Right? So this guy's name was Spearman anyway, that he was the inventor of all this. Well, not the inventor, he found it out. Right, okay, I'm looking at this stem and leaf plot here, diagram here. I'm looking at there's a males and it's contrasting males and females on the left and the right. I think we did this before. There's an overlap here. This is called the overlap. Okay, you can find the median by, you know how to find the median, you know how to find the most common one. Okay, now I said here, Moira drew the diagram because she thought that these two groups would be about the same. Okay, now this is about athletes running and now it's back to cycling and running. Okay, so do you think that the diagram would cause Myra to confirm her belief or change it? Okay, about the same. Okay, well, they are about the same, because you can see that there's an awful lot of overlap here, you know. I mean, they're not one is on and one is lower and one is higher. Okay, so yeah, you know, 30 males and 23, I found out that 30 males and 23 females have times between 15 minutes and 21.3 minutes. That this adds some sort of credence to the belief that they are very similar in athletes, but you know, time is relative. You know, 1 second could be, you know, a lot when you're dealing with running or velocity. Okay, so that's that for that part. I don't know whether there's going to be more videos after this, but if you buy into the program, you know, if you go to the website and you see what I'm doing there and you like what I'm doing, you know, for a small fee you can get extra videos, you know. Okay, try and do some questions. Good luck.